All right, problem 2 brings us to a word problem. Yay! Demographics. Population density describes the number of people per unit area. That makes sense, right? Like how many people are in this particular area. During 1 year, the population of Angola, I hope that's how you say it, Angola. Yeah, it is Angola. I just checked with my husband. Angola. So the population of Angola was 1.21 times 10 to the 7th people. That's a lot of people, guys. The area of Angola is 4.81 times 10 to the 5th square miles. What is the population density of Angola that year? So this is how many people. This is how big the place is. So this one says it's people per unit. So what we're going to do is we're going to write 1.21 times 10 to the 7th people over 4.81 times 10 to the 5th. And that's the area, the square area, the unit area. And we're just going to use the rules that we just had. So this is people over area. Okay, because that's what the problem said to do. People over area. Now, you see the tens? Where's the party at for the tens? Party's upstairs, right? How many more? 2 of them. Now, the 1.21 and the 4.81, we're going to have to deal with separately. All right? So I'm going to rewrite this like this. Watch. 1.21 divided by 4.81 times 10 squared. So I'm just kind of like separating it. Okay? That's allowed in any type of math. You're allowed to do that. Now I'm going to get my handy dandy. Here it is. 1.21 divided by 4.81 is, let's just do 0.25. Miss Sattler can teach you about significant digits some other time. 0.25 times 10 squared. Oh, but bummer. You remember that silly scientific notation? Your decimal belongs between your 2 and your 5. So if you have a positive decimal already and you're moving it to the right, that's going to make it 2.5 times 10 to the 1st. And this is how many people. And since our area was in square miles, this is how many people we have per square mile. So what that means, guys, is if you had like a 1 mile by a, I'm just trying to make this make sense to you. If you had a 1 by 1 mile area, 2.5 times 10 is just 25. I hope you guys know that. 2.5 times 10 is just 25 people. So think about it. If you had 1 mile by 1 mile, that means 25 people live in that particular area. So that's what the problem is trying to get at. All right? Let's continue on. During 1 year, Honduras had a population of 7.33 times 10 to the 6th people. The area of Honduras is 4.33 times 10 to the 4 square miles. What is the population density of Honduras in that year? Now this population density, I don't really think that's that bad. Like I think I live in Beaver Falls, you know, like a 1 mile by 1 mile area, I can guarantee you there's more than 25 people. I mean, where I live, I can't even tell you, it's a lot. There's a lot of people that live in a 1 by 1 mile area because we live in a very congested town. Okay? 25 is not that much. Let's take a look though at Honduras. So we take how many people, 7.33 times 10 to the 6th, remember this is people over the area, 4.33 times 10. We could do this for Hookstown. We just actually have to get some numbers online maybe tomorrow. Maybe that could even be bonus. Oh, I said the word bonus. Maybe if you guys come in tomorrow and tell me how many people are in Hookstown, figure out the population, and then you guys figure out what's the square area in Hookstown, or in maybe even Southside School District might be better. Look how many people live in the Southside School District, and then look how big the Southside School District is. We could do a problem like that. All right, but back to Honduras. Where's the party at for the tens? The party's at the top, right? So we get 10 squared on the top. And that's going to leave us with 7.33 over 4.33, which I actually have to divide out on my calculator, okay? So I'm going to put this on my calculator here. 7.33 divided by 4.33 makes 1.69 when we round. Times 10 squared. Well, remember this is how many people there are per square mile. Now, does that make sense that you have 1.69 times 10 squared people? Not really, right? You know scientific notation, you just move that puppy over. That's 169 people in every square mile. So, Angola, up here, Angola, my husband says it's Angola. Alright, whatever. Angola, up here, only has 25 people per square mile. Look at Honduras. Honduras has 169. Is that more people? Yeah, by a lot, right? So here's 1 mile. Here's 1 mile on a map. If you were to list all the people in that square mile, there would be 169 people. So what have we learned? Here we go. Cross-curricular. What have we learned? We've learned there Honduras is much more densely populated than Angola. Is that right? My husband says that's right. Okay, let's move on. See, look at that. History and math in a lesson, or geography. All right, let's have some more fun. You can use repeated multiplication to simplify a quotient raised to a power. Have you seen this before? Absolutely. We studied it way back in 7-1. In other words, guys, you see when you have parentheses, that outside exponent goes to everything inside. You can do it the extremely long way that the book did it, because it is kind of nice to explain it the long way. But you can just know that, long story short, the exponent gets distributed to everything. But yeah, it is because you have 3 x's and 3 y's. That's why it works the way it is. Here's the algebra part. Here's the example part. Now let's do it together. Multiple choice. It's like it never happens, right? Multiple choice. Z to the 2/3, that says 2 over 3, all over 5, and all of that is raised to the third power. So essentially what happens is that 3 gets distributed to the 2/3, and that 3 gets distributed to the power of the 5. What is the power of the 5, please? It's a 1. So we get z to the 2/3 times 3, because the exponent gets that outside 3. And then we get 5 to the quote-unquote first power, right? Because it was the first power. Write that down, please. If nothing's there, it is a power of 1. I think you know that, but just in case, write it down. Well, 2 over 3 times 3, you should know the 3's cancel out, and you get z squared. And 5 to the 1, that's just 5 to the 3rd, because 1 times 3. Well, you guys better know 5 to the 3rd is 5 times 5 is 25, times 5 is 125. You know some people are going to be tempted to say 15 there, right? They're going to do 5 times 3 instead of 5 to the 3rd. Now let's look for my multiple choice answer. I found it. D is the answer. I can almost guarantee you on the keystones, they're going to have B as an option, because some people are going to do 5 times 3 and get 15. Moving on to got it 3A. What is the simplified of 4 squared and x cubed squared? Well, the squared goes to the 4, just like that, and the squared also goes to the x cubed. So you have to do some multiplication. We learned that in section 7.3. So 4 squared is 16, and that becomes x to the 6th power, not to the 5th power. Well, that one isn't too hard. Part B, reasoning. Don't stress out, you'll be fine. Describe 2 different ways to simplify this expression. A to the 3/4 over a to the 5th, all to the 4th. What method do you prefer? Well, I can show you the mean way, okay? Because there's 2 ways. There's the mean way and there's the nice way. Okay, mean versus nice. Let's get the icky one. Let's get the mean one out of the way first. You could simplify inside first. Simplify inside first. Yeek. So you have to do, ready? You would have to answer this question, where's the party at? The party's on the bottom, right? Party's on the bottom. So you have to do 5 minus 3 over 4. Well, 5 minus 3 over 4, I'm going to cheat because I can. Being lazy, oh my goodness. Well, 5 minus 3 over 4 is 17 over 4. And since the party was on the bottom, that becomes 1 over a to the 17 over 4. Now, if you would have just subtracted 3 over 4 minus 5, are you paying attention? If you would have subtracted 3 over 4 minus 5, you would have got negative 17/4, and that would have told you it belonged in the bottom. But I did that party thing, so I didn't have to deal with that. And then that's all to the 4th power. So the 1 gets the 4 power. The a to the 17 over 4 gets the 4 power. And 1 to anything is 1. And here the 4's cancel out, and you get a to the 17. That really was kind of painful. At least in my opinion, it was a little painful. Maybe, I don't know. Maybe you really enjoyed it. I'd be surprised. So you get a to the 3/4 over a to the 5th, all to the 4th power. You ready to see a prettier way? Well, the a to the 3/4 gets the 4. And the a to the 5th gets the 4. So the 4's cancel out here, and you're left with a to the 3rd. And down here you get a to the 20th. And now look how much easier our quote-unquote party problem is. Where's the party at? Downstairs. How many more? 17. That looks funny. Let me fix it. And then if there's nothing left up top, because all of them would go away, 3 would cancel with 3 of these. That's how we're getting 17. That's it. So you can pick which method you like. This is more algebraic. This is, I don't know, this is algebraic too. I just like it better. You can pick whatever you want though, as long as you get it right. I don't really care. Ready for the next one? We learned this in 7-1. We saw this. Okay? In 7-1, we did see when we have a negative exponent for a fraction. What I made you do in 7-1 was, well, I didn't really tell you there was a shortcut, but there is a shortcut. Let me give you an example of 7-1. In 7-1, if we would have had 3 over 4 to the negative 2 power, I would have made you do this. I would have made you make that 3 to the negative 2 and 4 to the negative 2. And quite frankly, in 7-1, you had no idea that I was actually making this problem harder than what it needed to be. Well, then I would ask you, well, what needs to happen? And hopefully you guys would say these need to switch. So you would get 4 squared on the top and 3 squared on the bottom, and then you would get 16 over 9 as your final answer. Well, let me tell you what happens in 7-4. In 7-4, this problem can be made it's a lot faster. 3 over 4 to the negative 2 power could be written as, here's what this rule up here says. It could be written as 4 over 3 to the positive 2 power. And look, the negative went away, and I flipped my fraction. That's essentially what the negative does anyway, right? So that's 4 squared is 16 and 3 squared is 9. So a little shorter, a little easier. But honestly, unless you really understood 7-1, this would just be a rule to it. It wouldn't make any sense as to why it worked the way it worked. So yeah, there's always a reason behind my madness. Okay? So in problem 4, you can sit here and distribute your negative 3 if you want to. I really would not sit here and distribute my negative 3. All right, here's what I would do. You know what? I think this video is pretty long. Let me do another one, okay? I know you're excited. Just hold on and go to the next video.